make sure y'all interact with me this morning because the 12023 class did not interact with me the yesterday morning. So I ended up going through all of chapter 5 in like 45 minutes. So you better ask questions and you better, pay attention. Because one, I don't think they were paying attention because I was going over some stuff and I didn't get a single question. So either they're all very smart or they've already had this material before, and out of 20 something students, I don't believe that, or they wasn't listening, one of the two. So I just went through the whole unit, which is 3 or 4 sections in 45 minutes, and they didn't say a word. So
it was probably the first one.
Yeah, they all smart. That's probably what it is. 25 students, and every one of them smart as a whip. No. Because there's one rule in life besides nothing is free, and that rule is there's always one. There's always one in every group. I don't care if it's at work. I don't care if it's at school. I don't care if it's with your friends that you hang out with. If something happens, there's always one person that's either going to screw it up or make it worse for everybody. So there's always one. So I'm just telling you right now. All right. And nothing is free. All right. So here is my handy dandy whiteboard. And we're going to go over probability. And I don't know how much I've covered a probability. Have I covered any probability in this class?
I don't think so.
Okay. All right. Probability. There's a road in Anderson, and it's West Anderson. This is West Anderson right here. That's where I live, West Anderson. Townville's up this way. I-85 runs through the middle. And then there's a road that's called Wild Hog Road. And Wild Hog Road goes to Pendleton and Sandy Springs. And the thing about this road, it's about, I don't know how long it is, but I know it takes about 15 to 20 minutes to travel. Of course, I know there's somebody in the group that can travel it in 5 seconds. There always is some idiot that says he can travel. And notice I said he says he can travel it in half the time everybody else can. But anyway, it usually takes the normal person that's got sense to about 15 or 20 minutes. It's straight. There's a lot of traffic on it, so you can't pass. And every time you get on Wild Hog Road, the Little Blue-Haired Ladies Club gets in front of you. Who is the Little Blue-Haired Ladies Club? They're the ones that go 35 miles an hour and sets it on cruise at 35 miles an hour. And they get in front of you. This happens all the time. I traveled Wild Hog Road for the 16 years that I was at the Pendleton campus. I traveled this road every day. And you always get behind the Little Blue-Haired Ladies Club whenever you get on this road. I don't care if you're coming from Pendleton or if you're coming from Anderson. And you travel and you turn a 15 to 20 minute trip into a 30-minute trip. So you always have to plan for 30 minutes when you get on Wild Hog Road. Pendleton High School is right here. And the Waffle House in Pendleton is right here. And this is 76. There's a red light right here. Red light. And when you get about 500 feet from this red light, you say to yourself what y'all will say every time y'all get behind a slow person. I bet that person is going to turn left. And you get up here about 200 feet, and guess what? They turn on their left blinker. have you just foretold the future? Have you just predicted the future? Yes or no? It's an easy question. Yes or no? Have you just predicted the future?
No.
No, you did not. Because no one can predict the future. No one can predict the future. No one. So if you ever meet somebody, like I had a friend, a former friend, notice the word former, and she said that she could, if I wrote down my dreams, she could tell me my future by interpreting my dreams. Now, I want everybody to let that sink in. All right? I write down my dreams, and she could interpret those dreams and tell me my future. One of the reasons that we're former is because I said she was a nut. Why did I call her a nut? Who makes up your dreams? Come on, people. Who is the author of your dreams?
You.
You. So I need somebody besides me to take my dreams that my brain came up with and tell me my future based on my dreams that I came up with. I want somebody to tell me how much sense that makes. Nobody's going to say anything. If anyone tells you that they can predict the future, all you got to do is ask them one question. Anybody know what that question is? All you got to do is ask them one question, and they'll start, Anybody?
Nope. Don't know the question.
You don't know the question. Give me the lottery numbers. Oh, well, that's not what I do. No, you're a con artist. Get away from me. How many of you have played 20 questions before? Anybody?
I think in this situation, you're also a con artist.
Who, me?
Yeah, if you're asking for lottery numbers.
Yeah, that's the whole point. They can't answer the lottery, the winning lottery number. Let me put winning. If somebody walked up to me, if Miss Gravina walked up to me out in the open, strangers, and said, I can tell you your future if you give me $25. I say, well, I tell you what, you tell me the winning lottery numbers and I'll split it with you. Oh, that's not what I do. You're a fraud. Get away from me. Why? What is 20 questions? Somebody tell me how you play 20 questions. Oh my God. You know, y'all's parents suck. All right. Y'all have never played 20 questions before. There's somebody in here who's played 20 questions, and I want them to speak up right now. Come on. Nobody. Nobody in this room has played 20 questions before.
Is it not where you just ask the other person 20 questions about themselves?
Or 20 questions about what they're thinking of.
Yeah.
That's it. Yes. All right. What is this game based on? It's based on what? It's based on deduction. Now, what else goes into the foretelling the future? Well, first of all, let's say that I have a little building at the jockey lot, and it says, I will tell you your future. Or I'm a palm reader. And Miss Poor walks in to my little business and hands me $50. right then I know that she's not sure of herself or she's already depressed, one of the two. All right, think about it. Who walks in to a place and gives somebody $25 or $50 to tell them the future? Somebody that is worried, or somebody that is depressed, or somebody that is not sure about what's going on in their life. And what is that person? What is that person that can tell the future? What are they going to start doing? They're going to start asking what? Questions. You go walk into any place that tells the future, and they will do that. Now, why am I spending so much time on this? Because anytime you're talking about somebody telling the future, there will be something with deduction in it. Whereas, how did I tell the future right here? I predicted, write this down, an outcome based on experience. I usually experience, logic, or mathematics. I predicted an outcome based on experience, logic, and mathematics. All right, somebody tell me, what in the heck am I talking about? Hold on just a second. I'm going to change this a little bit. There. Does anybody know anything about Wild Hog Road? Well, first of all, if I'm on Wild Hog Road and I get on Wild Hog Road right here, 90% sure I'm from West Anderson. I'm not from Townville. Because if you're from Townville and you're wanting to go to Pendleton, you're going to hit I-85 and go to the Clemson Boulevard exit, or the Clemson Boulevard exit. Yeah, that's what you're going to, because there is no, because of the lake and because of everything else, there is no other highway to get to Clemson or Pendleton unless you go Seneca Highway 59 or Conroe's Crossing up there. There's no other way to get to Clemson. Everybody understand that? So if you're on Wild Hog Road, you're from West Anderson, okay? And going this way. Everybody with me? Another thing, how do I know they're heading to Pendleton? Because I know Wild Hog Road. And if you're going to Sandy Springs, there is at least 3 other roads that go to Sandy Springs. So if you are at the end of this highway, Wild Hog Road, what is the only logical conclusion based on logic and experience that you're going to turn? You're going to turn left. You're not going to turn right up here, because you could have turned right here, here, and here to go to Sandy Springs. So I used logic and experience to foretell an outcome at the end of this road. How many times have y'all done that before? You've done it before. You've gotten behind somebody really slow, and you said to yourself, I've got to hurry and I've got to turn left up here. This person's going to turn left. And how many times do they turn left? You've done it before in your head, okay? There is no such thing as telling the future. But I can use deduction, logic, and experience to assign a number between 0 and 1, write this down, based on logic, experience, and statistics. And that is the definition of probability. Assigning a number between 0 and 1 based on logic, experience, and statistics. Any questions on that? Now, there's two types of probability. We'll go over two things here. Assign a number between 0 and 1 based on logic, experience, and statistics. Now, if you want to read, we'll go read the, hold on a second. I'll let y'all read the definition of probability right quick. And if you want to go with that, you're welcome to go with it. Somewhere in here. The measure of likelihood of a random phenomena or chance behavior occurring. Probability describes the long-term proportion which a certain outcome will occur in situations with short-term uncertainty. Yeah. All right. So, layman's terms, assigning a number between 0 and 1. Probability of an event happening is written as the probability of E, and that is equal to the number of times something has occurred over the number of times something can occur. Now, there's two types of probability. There is what I call the theoretical probability, and the physical probability. Does anybody know the difference between the two? Well, I tell you what, Mr. King, what is the probability of picking a king out of a deck of cards? Do you know that?
It's 4 out of 52.
Okay, everybody, look at Mr. King's picture, and Mr. King is going to hold up his deck of cards. Hold him up.
Hang on, I need to go.
He don't have a deck of cards. How do you know that?
I can get some if you need.
No, cooperate. Run with me here, okay? Cooperate. All right, you don't have a deck of cards. Miss Gravina, what is the probability of a 7 on a die? Do you know that?
Don't believe I do.
Okay. How about you, Miss Poor? A 7 on a die.
Is it 0?
0. How do you know that? Because she has a die right there in front of her. Everybody show her your die. Show the class your die you have in front of you.
I don't have one.
Oh, so Mr. King and Miss Poor are magical. Is that what they are? They can tell the future. They can interpret your dreams. Write down your dreams, everybody. How did they know that if Mr. King don't have a deck of cards in front of him and Miss Poor does not have a die in front of her? How did they know that? It's based on knowledge of something. Based on knowledge Theoretical probability is based on knowledge. What is the probability of tails on a coin? One out of two. I don't have a coin in front of me. But how did I know that? Because you know there's two sides of a coin, and I don't think, has anybody ever flipped a coin and it ended up on the edge? No. Unless it's the equinox, and you can stand a broom up on the equinox or the egg. You might be able to do that. I don't know. Some of y'all have no idea what I'm talking about. After 12 years of school, have no idea what I'm talking about, and that's really sad. All right. Physical probability is something that you what? You observe an event. Let's say that Miss Poor does have a set of die or dice, and she takes one die and she rolls it 10 times. She rolls the die 10 times. And after she rolls the die 10 times, she comes to the conclusion that the probability of a 6 is 2 out of 10, which is equal to 1/5. Okay, that is called physical probability. Now, some people call it relative probability. Some books call it relative probability because you are actually doing an event or observing an event. Capiche? Everybody understand? I know I can see 3 people, but the rest of y'all are hiding, and not communicating, except for Mr. Butcher. He communicates every now and then when he's awake. Everybody else understand besides those 4 people? Can I get one person to say that, that doesn't communicate or show themselves? Can I get one person to say that they understand? And that would be a no.
I understand.
Thank you so much. Oh my gosh. Who was that? Was that Miss Yarborough?
Yeah.
You know you're gonna get chastised for talking, Miss Yarborough. You know that, don't you? So the other students, they don't like that. All right. So what else? What else about probability before we actually do some problems in probability? Well, as I told you, probability is between the probability of an event is going to be between 0 and 1. That means that this is very unlikely. And this is very likely. And I really don't know if likely has an E in it or not. I have no earthly idea. So I'm just going to put it there, and I'm sorry. We also know that the law of large numbers tells us that the more events you try, the closer the physical probability approaches the theoretical probability. Okay, I'm gonna have to go ahead and fix this because this is not cooperating. I tried to fix it to where I could do the whole screen, and it's just not working. I tried that for y'all, and it's just not working. So I'm gonna have to take it off of full screen. I'm sorry. It just does better this way. Okay, so The law of large numbers tells us that the more events that you try, the closer the physical probability approaches the theoretical probability. Basically, CYA. And if you don't know what CYA means, it's your parents' fault and 12 years of school is fault. Okay? When you are doing a presentation and you're being paid 5 or 6 figures to be a director of quality assurance, you're not going to pull 10 examples. You're going to pull 10,000 examples. Are you going to survey 10,000 people instead of 10 people? The law of large numbers basically means that if you're going to do a presentation, you better make sure you pull a big sample, because the bigger the sample, the more accurate the data. Okay, you could write that down if you want to. The bigger the sample, the more accurate the data. And that's why I put CYA on the bottom. I don't care if you're doing probability or statistics and you're presenting to a department or a division or the whole dadgum company, you better make sure your sample is big enough to cover your backside. Okay? And that's what the large number rule tells us. And remember, there's 2 types. There is the physical probability, which is the observation. And then there is the theoretical probability. Both share the same number of times something occurs over the number of times something is tried. That's the formula for both. Also, do not use percents. Do not walk into, especially somebody that eats, drinks, and sleeps, statistics, like a psychology teacher. Oh my gosh. And you're talking about probability, and you say, well, there's a 75% probability they'll have conniptions and start doing convulsions. Okay? You're talking about decimals. When you're talking about probability, you always speak in terms of decimals. Walking into a probability course and saying 75% probability is like walking to an English course and saying ain't. Don't do it. Now, in this class, I really don't care, but percent usually is talking about chance. And you can change a decimal into a percent, and basically you're saying from probability to chance. A 0.75 probability equals 75% chance. You ever heard the weatherman say 75% chance of rain? Well, it's easier to understand a 75% chance of rain than the weatherman saying, well, there's a 0.75 probability. Do you see what I'm saying? It's easier for people to hear 75% chance. All right, but if you walk into a statistics geek type setting, they'll have a fit if you say 75% probability. That's just don't go together. All right, so let's see. Oh, here is the #1 rule of probability. This is a Hubertism rule. The math is not the problem. The math is not the problem. What is the problem with students and probability? Anybody want to take a guess if the math is not the problem?
The reading is?
How did you know that, Mr. Butcher?
I'm a psychic.
That's it. Will you tell my future? I'm very unsure of myself, please. I'll give you $100. Reading the question is the problem. Most people don't read the question. What is the probability of an even number in a deck of cards? Well, the student don't pick up the word even, or they don't know their deck of cards. The probability of an even card in a deck of cards would be equal to 2, 4, 6, 8, 10, Jack, King, Queen. 1, 2, 3, 4, 5, 6, 7, 8. There's 4 suits, so that's 32 out of 52. Now this is real simple math. This is basic math. But either you don't read the question and pick up that they're asking for the even cards, or you don't know about a deck of cards. I would highly suggest that you learn the deck of cards in this chapter, okay? And a die. And a coin. Those are the 3 things. And one more thing, but I'm going to tell you to write an index card on it. But those are the 3 things right there that you should know right off the top of your head. What is the probability of a face card? Well, I just told you that there's 3 face cards. So that's 3 times 4, which is 12 out of 52. And you always reduce your fractions. I'm not going to worry about that because most of you can reduce your fractions. All right. So the number 1 rule that students have problems with is not the math. It's the reading of the question. Now, why do I do this? Because you all are going to go through this probability section and you're going to come to me with a homework question. You're going to say, I don't understand. And it's all because of one word, and, or, the word, or. And, or, the word, or. 2 words, 2 little words. One's got 3 letters, one's got 2 letters. And it's going to stump you on, reading the question. All right, let's look at the PowerPoint and let's see what I've covered so far. So we covered probability. Okay, event and outcome. There's law of large numbers. Let's see event. They don't have the word event, do they? Okay. Event is you flip a coin. Outcome would be you flip a coin 10 times. All right. So an event is something that happens when you flip a coin or roll a die. An outcome is if you do it 10 times. That's not a real big deal. That's really not that important. There's the law of large numbers. As the number of repetitions of probability experiment increases, the proportion to which a certain outcome is observed gets closer to the probability of the outcome. Yeah. The physical probability, the more times you do an event, the closer it becomes to the what? The theoretical probability. That's what that says. Go ahead and knock yourself out. Yeah. There's experience. Okay, sample space. Make sure you write these 3 down. Okay, an experiment is a process that can be repeated in which the results are uncertain. Now, we all know that because we talked about experiment versus an observation. What is a sample space? Well, we're going to talk about a sample space in just a minute. The collection of the possible outcomes. Just put a sample space equals collection of all possible outcomes. An event is a collection of outcomes. I had that backwards, I'm sorry. An outcome is like you flip a coin and get heads. An event is you flip a coin 10 times. And you write down the outcomes. Okay, you flip a coin 10 times and you get 10 outcomes. And you write them down and you do your math based on those 10 outcomes. That's an event. Outcome is just one time. I had them backwards. All right, so the sample space should be coming up here in a minute. Okay, we're going to go back here. I'm going to go now. I'm talking to probably 5 people that did this. You remember me telling you to do this? Okay, and 5 or 6 of y'all did it. The rest of y'all didn't. Well, we're going to do another one, and this one's going to be an index card, and you're going to divide it up into 3 sections. So for the 5 or 6 people that's going to do this, the first one is going to be 2 children. The second one's going to be 3 children. And the third is going to be 4 children. And these are called sample spaces. Now I'm going to do the first one because the first one is real easy. You have a boy, 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 girl, girl, boy, girl, girl. And that one everybody can come up with. The third and the fourth is not so simple. So what I tell students to do is just make it easy on yourself. Look up 3 children sample space. And do an image. And it usually comes up. There it is. Forget the tree. You don't need to do the tree. So boy, boy, boy. Boy, boy, girl. Boy, girl, boy. Boy, girl, girl. Girl, boy, boy. Girl, boy, girl. Girl, girl, boy. And girl, girl, girl. And that's your second set. And then the 4 children is in your PowerPoint. It's in the, it's in the 103 PowerPoint. Let's go look up 4 children. 4 children. And there it is. Boy, I'm going to go backwards. Boy, 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 boy. Boy, 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 girl. Boy, boy, girl, boy. And boy, girl, boy, boy. And girl, boy, boy, boy. And boy, boy, girl, girl. And so on. I'm just going to write dots. You need to do this. And get girl, 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 girl. There's 4 here. There's 8 here. And how many do we have here? Probably 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 16, 12, 13, 14, 15, 16. Now, I would highly suggest for the 5 people that's going to do this to make an index card probably a big index card, and divide it into 3 sections and do these sample spaces. Okay? The 5 people that do this, you're going to have a pleasant doing your homework, doing the test questions, where the 15 people or the 10 people that don't do it, they're going to have to try to remember these sample spaces, and they're going to end up, you know, going crazy trying to remember them. All right? So make sure you pull them up and make sure you have 4, 8, and 16. And these are called sample spaces. Nobody is going to go out and have all these children physically. All right? So these are possible outcomes. A sample space is a collection of possible outcomes. That's the difference between a sample space and an outcome. Outcome is based on actually doing the event, whereas a sample space is a collection of possible outcomes. And hopefully you understand that. And that's basically what they're talking about with these right here. Boy, boy, girl. Well, let's go over this right quick and write this down. An impossible event. If an event is impossible, the probability of the event is 0. If an event is certain, the probability is 1. An unusual event that has a low probability of occurring. Let me ask you a question. If I tell you that the probability of an event is 0, are you going to tell me this is impossible? No. And that is a test question, and that is a standardized test question. I do not like to use these words in mathematics. Why? Why do I not like to use those 2 words? Why do I not like to use these 2 words in mathematics? Why? I don't mind this unusual event. I don't mind that. That's okay. Why do I not like these 2 words? Any of y'all ever heard of birth control? Is it 100% effective? No. Impossible is a word that you should not use, because just because something is 0 does not mean it's impossible. I do not like this slide, but I bring it up because it is a test question. There is a test question out there that says, if you have a probability of 0, does that mean the event is impossible? No, it does not mean an event is impossible. Well, then why do they have this written down? I have no earthly idea why I would like to see them put in, if an event is close to impossible, the probability is 0. If an event is close to certainty, the event is 1. But you will not find any mathematician or any statistician that will say something is what? Certain, or something is what? Impossible. When you get even lawyers know this, when you get a professional witness on the stand, are you going to say that something is impossible? The witness is never going to say, yes, that's impossible. No, because anything is what? Possible. So I spend a few minutes on this slide because the way it's written, I disagree with. An event is close to impossible if the probability is 0. Then an event is close to certainty if the probability is 1. But nothing is certain, and nothing is what? Impossible. So make sure you make that distinction on that question, because it will get you on a test. Capiche? Good. And I've already told you this. I'm not going to, well, that's the formula for probability. I'm covering stuff that's, you know, that's important. All right, so let's go over some examples before I go into 5.2. Because these are some questions I would ask you on a test. What is the probability of a face card in a deck of cards? And you would tell me, let's see, that would be 3 face cards times 4 suits. That will be 12. And then out of 52. And then that would be 6 over 26. And 3 over 13. So your probability of a face card is 3 out of 13. Somebody check my math. Make sure I didn't screw up anywhere. That's a possibility. Out of 5.1, I'm going to keep it simple. I'm not going to try to trick you. Probability of a 7 on a die. Well, as Miss Poor said, that's 0 because a die goes 1 through what? A die goes 1 through 6. There's only 6 sides to a die. Is this a test question on a standardized test? Hell to the yeah. Because they want to see if you got some common sense. So, and after you think about it, after you know that a die has 6 sides, a lot of people don't know that a die has 6 sides. You have to be introduced that knowledge. Okay? A lot of people don't know there's 52 cards in a deck of cards. So you've got to be introduced that material. So make sure you know a deck of cards or a die. What about the probability of tails on a, you know, probability of tails on a coin is 1/2 or 0.5. Don't remember, they want decimals. Somebody divide 3 by 13. Hold on a minute. I got IT to give me my new calculator software. There it is. It only took, let's see, this is 6 weeks. It only took 6 weeks to get it. Anyway, we're going to take 3 divided by 13. 0.2308. 0.2308. Y'all know I got this for y'all. I got this for y'all. Just wanted to let y'all know that. You're welcome. All right, so 0.2308 is your probability. Make sure you can, what is the probability of having all 3 girls? Well, that'd be 1 out of 8. So you go to your handy dandy calculator. And 1 divided by 8. 0.125. So make sure you know how to do questions, and they'll give you some questions in the homework, and you come up with those probabilities. Now, what do you do when you have to add or subtract? Additive law of probability and multiplicative law. Y'all were impressed that I knew how to spell both of those. Multiplicative and additive law. The additive law, you have to make sure and write in red. Does anybody know the one word that explains the additive law? Or. And what's the one word that satisfies the multiplicative law? And. I got COVID. I'm sorry. Or and and. In the additive law, you've got to remember always subtract the overlap. With the multiplicative law, you've got to remember to find out whether it's with replacement, which means independent, or without replacement, which means dependent. Okay, now these are the two things that you have to remember when you're talking about the additive law or the multiplicative law. If you have a question and it says, what is the probability of a king or a queen? Then you know you're dealing with the additive law. What is the probability of picking a king and a queen? That would be multiplicative law. So you have to read the question. Now, there's one more thing about the additive law. Try to create a table when you can. Try to create a table when you can. In other words, if you can form some kind of a table, then it's going to help you out with the additive law. All right, so here we go. I'm going to give you a good example. And I love using this example because you've got 4 or 5 different questions in one example. And I'm going to go over the additive law first. And here is the table that I'm going to give you. And this is also a good standardized test question. RH positive, RH negative. Okay, some of you nursing students, what are we doing here? Anybody know? A, B, AB, and O. What are we doing? Golly, y'all suck.
Is that the blood types?
Blood types. Way to go, Mr. Butcher. I don't know why my autofocus is not working. Damn Russians. Is that better? There. Yeah, Hubert, that's better. Thank you, class. Appreciate your interaction. Let's go with 12, 15, 10, 8, 3, 2, 12, and 10. Okay, I've got a table, and I want to know the probability of A or AB. Well, the first thing you got to do when you're working with the additive law or the multiplicative law, the first thing you do is you got to get a what? A total, because the total is going to be equal to the denominator. So add them up. Well, 10 and 12 is 22, 24, 27, 37, 45, 60. I got 72. Somebody tell me what y'all get. I know some of y'all are reaching for your calculators, especially those of you not on video. Go ahead and add them up. You might tell me what you get. Meanwhile, 15 minutes later, it shouldn't take y'all 15 minutes to add
I
up.
got 72.
Okay, thank you. Mr.
You're
Beanie, you
welcome.
know you're not supposed to talk. The other students are going to get mad at you. They already
It'll be
chastised.
all right.
They already chastised. Who was it a while ago that talked to me and talked to me since? Miss Yarborough. They already chastised Miss Yarborough and Mr. Butch because they're not supposed to talk. Mr. Butcher, they're not supposed to talk. Don't y'all understand the winged on a pickle? They rule. Don't you understand that? Morning vodka. Good stuff. All right, so 72 is our denominator. So I'm going to take my handy dandy highlighter. Now, is this something that y'all should do if you've never done this before? Yeah. And I'm going to highlight A. And that's going to be this section. And I'm going to take, since I do not like orange and pink clash, I cannot use it. I cannot do that. So I'm going to have to use yellow. And AB. So that's going to be, and yeah, I'm going to write in pink, yes, 12 plus 15. You're welcome. Plus 3 plus 2 over 72. And that is how you do the additive law. Now, I'm going to do another example here in just a second, and we're going to rewrite the whole table because I've already drawn highlighter on this one, so it's messed up. I'm going to have to redraw it. And I'll do that for y'all. Anyway, 12 plus 15 is what? 27, Hubert. That's right, class. Thank you for the interaction. Plus 5 over 72. And 27 plus 5 is 32, isn't it? And somebody, let's take our handy dandy calculator. Y'all know I'm playing with this calculator because they finally gave it to me. So that's why I'm using it. 32 divided by 72. I know I'm a geek. 0.44, repeating. So what is the probability of, let's say you put all these people's names in a hat. What's the problem putting their blood type beside them? What is the probability of picking somebody A or somebody AB? You got a 44% chance or a 0.44 probability. Now let's do it, and let's, oh yeah, I forgot to do the overlap. There is no overlap here. So there is no overlap, so you do not subtract anything. Now let's do it again, and I'm going to rewrite the numbers. RH positive, RH negative, A, B, AB, and O. Yeah, I know. I go through a lot for y'all. I rewrite everything, do the colors and everything. You're welcome. 15, 10, 8, 3, 2, 12, and 10. You would think all teachers would do that. I'm going to tell you, there's actually some teachers that make this difficult. I'm going to be honest with you. I've had to sit in their classroom and look, and they would confuse me. And it's sad, but it's true. What is the probability of AB or RH negative? We know it's over what? 72. So I take my handy dandy yellow highlighter and I do AB in yellow. And then I take my pink highlighter and I do RH negative. Oh my gosh, what do I have? I have a what? An overlap. So I put in my, oops, sorry, hold on. Getting ahead of myself here. So I put in my 3 plus 2. And then I put in my pink plus 15 plus 8 plus 2 plus 10. And then I subtract my what? You always subtract your what? Your overlap, Hubert. Thank you, class. Thank you for the interaction. I appreciate it. And that's going to give me 5 plus, let's see, 8 plus 2 is 10. 10 plus 10 is 20. 20 plus 15 is 35. And 2. And that's going to be plus and minus over 72. 40 minus 2 is 38. So we got 38 over 72. 38 divided by 72. 0.5278. And that is how you do the additive law. That's why it's crucial to try to make your paragraph into a what? A table. If you make your paragraph into a table, it makes the problem a whole lot easier. So you've got one without an overlap, and then you've got the other with the overlap. Overlap with the two colors. What does pink and yellow make? A light orange. So here's the overlap. There you go. Believe you me, I've had people ask me after I do this problem, where did the 2 come from? The 2 is the overlap. Everybody good? All right, I'm going to try to squeeze in 5.2 right quick with a bag of marbles. Now, for some of you Marlboro Club, I didn't say Marlboros, I said marbles. Y'all are impressed, aren't you? That's a bag of marbles. You know, I wish I could have interactive classes that actually talk and make comments, and I just don't understand why it's so impossible for a class to talk. Why is it so impossible? Is it because you hate me? Is that what it is?
I mean, I'm not gonna lie, drawing that bag that well was pretty
I
good.
appreciate it. Thank you. 5 marbles are green. 3 marbles are red. And I write red and blue. I suck. Blue. Too much vodka in the morning. 4 are red. And my favorite color, 5 are yellow. I want to know the probability of 2 greens, of picking a green and picking another green. I just screwed that up. There we go. I want to figure out if I pick 2 marbles out and I want with replacement. In other words, if I pick a marble and I look at it and I record it on a piece of paper, I put the marble back in the bag. That's called with replacement. So somebody tell me, what's the total? 5 and 4 is 9, 12, 17. So 5 out of 17 times 5 over 17, which is 5 over 17 raised to the what? Second power. So right quick, somebody, well, I'll do it. Because 1, y'all won't do it right, and 2, y'all won't tell me unless you tell me the wrong answer. So I might as well just do it myself. 5 divided by 17 raised to the second power. Y'all check me. And that's 0.0865. So what is the probability of me pulling 2 green marbles out right behind each other? Less than a 10% chance. All right, now let's do without replacement. That means that I pull a marble out and I put it in my pocket after I record it. So I'm going to draw it again. And I got 5 green. If y'all don't mind, I'm not going to write the word. 3 blue, 4 red, and 3 and 5 yellow. And we've already established that that is a total of 17. And I want to know the probability of a green and a probability of a green without replacement. That means I'm going to put the marble in my pocket after I record it. 1 color, and then I put it in my pocket. I don't put it back in the bag. So the probability of green is 5 over what? And then what? I put it in my pocket. How many greens do I have to choose from? Not 5, but what?
4.
4. And how many are in the bag?
16.
Not 17, but 16. This is without replacement. Without replacement, you can't use your exponents. So, take my handy dandy calculator, and I take parentheses 5 over 17 plus, or multiplied by, parentheses, 4 divided by 16. And that comes out to 0.0735. So that dropped, that changed the statistics, because instead of 17 marbles to choose from, you're only picking from 16. So without replacement, meaning dependent, the stats, the actual math, what? The actual math changed, because instead of 17, you're going to pick from 16. So that's called dependent, which means that the stats change. And that's why we get a different answer. With replacement, I put the marble back in the bag. Without replacement, I take the marble and put it in my pocket. Now I want to show you one more thing. I'm going to change this bag. And now we're going to do 500 marbles, 300 marbles, 400 marbles, and 500 marbles. And we all know that that's 1,700. Now, what is the probability of a green and a green with replacement and the probability of green and green without replacement? So this is going to be 500 over 1,700 raised to the second power. And somebody give me 4 decimal places on that. And this one is going to be 500 over 1,700 times 499 over 1,699. And I'll do that one in the calculator. So somebody do the first one and I'll do the second one. So parentheses, 500 divided by 1,700, close parentheses, times 499, sorry. Oops, I got to put my parentheses. Parentheses, 499 divided by 1,699, close parentheses. And 4 digits, I get 0.0864. Somebody give me 4 digits up here. That's all right, I'll do it. Appreciate the interaction. 500 divided by 1,700 raised to the second power. .0865. Well, what was the other one? Okay, 0.0864. Okay, somebody tell me what did I just prove? What did I just prove to y'all? Okay, let me go back here because evidently I'm not making a connection. All right, because nobody's saying anything. Y'all getting to be like that 12023 class. All right, look at here. Here's the probabilities with just 17 marbles. And here's the 2 different methods with 1,700 marbles. What's the conclusion? Y'all kidding, right? Y'all can't come up with a conclusion.
It looks like the bigger marbles have a closer number together.
The larger the quantity, the more it doesn't matter which method you use. The larger the quantity, the less the methods used mean. In other words, it doesn't matter which method you use. What's the larger quantity? I tell students 3 digits above 300. Anything above 300, pretty much it doesn't matter which method you use. Now you got to write that down, because in some of the cases on the test, they don't tell you a method. They just say solve. And when you got big numbers above 300, it ain't gonna matter which method you use. And it's gonna save you a lot of time on the test, because this method takes longer than this method, because you're using what here? An exponent. This method, if I ask you for the top 5, it'll take you twice as long to do this method than this method. So if you're dealing with 1700, I wouldn't even do this method. I'd just do this method. Capiche? Okay, y'all are pissed off at me or something. Y'all talk to me and then you stop talking to me. What is it? Okay, that's fine.
It's just a lot to take in.
Oh, okay. Well, that, at least say that. Thank you. Right now, y'all are responsible for 5.1, 5.2, 4.1, and 4.2 homework. I have covered that. There's no questions on 4.1 and 4.2, so it seems to me that y'all understand that. So y'all should be working on 5.1 and 5.2 now. Let's check the roll and see if anybody came in. Turn off the recorder.